I wanted to make one more full demonstration video of this demo board before the end of the semester. And this is the proof of concept board for two things in our overall design. It's been a full year of working with the Boeing military aircraft urban rescue design problem. And you can check out our other video for the full scope of the project, but basically we had to design an aircraft. And myself and Gaivorlor Borbor make up the electrical engineering department for the design of that aircraft. This is a proof of concept for two aspects of our design. So, the primary aspect is that the aircraft is actually autonomous, and our approach to creating an autonomous system is basically hinging on a really effective way of sharing information. You have to gather the right information, share it, and then make the right decision based on that information. And primarily that is for navigational things. So this aircraft needs to understand exactly what's going on around it. And the system needs to have a very accurate, a perfectly accurate reading of obstacles. Anything that is a threat to the vehicle it needs to know about, and it needs to be able to make a decision based on shared information in order to fully understand the environment it's operating in. So that's the primary thing, is that it needs to be a very effective network. And the secondary thing is that if that autonomous system fails, we have a crew member on board, and we need to make it really easy for him to safely land this aircraft, to save the lives of the people on board and to save the aircraft itself. So we have a first-person view system set up, and you can actually see the goggles there on the right. They don't show up very well on video, but you can see the same feed coming through this little 7-inch display. So we'll talk about that as well. But first, an overview of the board. You've got 3 fans that represent the actual rotors of the aircraft. It's a 3-ducted fan system. And you can see, let's see, there are total of 6 Arduinos here inlaid on the board. There's the 4 on the top, left and right, and the 2 there in the center. There are 2 LCDs you can see. And so it's a total of 6 microcomputers that are networked together using I2C, which is bus topology, and that is basically that means that they're all talking and listening on the same line. It's a conference call, and they're all working together, sharing information, and then making decisions based on shared information. That is the proof of concept here. So let's take a look. Here you can see the 2 LCD screens. And these came in as raw hardware. So part of it was that I had to learn how to register touch, and I also had to learn how to paint the background. This one is much easier than this one, but this is what's called a resistive touch screen, and basically it's 2 filaments, and when you touch them they make an electrical connection, and then based on the resistance values in the XY planes you can tell sort of where the touch happened. So it's pretty accurate on this one too. And over here, got a little custom graphic, a little Aggie pride, never hurt anybody. Okay, and so the proof of concept here is that this one is going to broadcast information, and this microcomputer is going to make decisions based on that information. So I'm going to send it that it needs to, I'm going to broadcast on the network that somebody needs to do an animation. And there it goes. So it immediately responded to that call. And so, for example, if this one was identifying a target or an obstacle, this one is responding to that obstacle. Yes, okay. So, you can also see with these fans, we built in some maneuvers, and this is going more towards the manual override to make it much easier for the pilot, who's not a pilot, to actually safely navigate to the ground to land it. And so I just sent a maneuver which caused this fan to slow down and the other 2 to maintain their speed. So that would effectively cause it to bank to the left. Or right, I'm sorry, it's flying towards us. And this is the opposite, where it would bank to the left. So this one picks up speed, this one slows down. So it would be able to turn the aircraft. Alright, and that's it for the shared network. It is sharing information and then making navigational decisions based on shared information. And that would empower the aircraft to actually pilot itself. With the advanced sensors we're going to have by 2040, and the computing power where we can create those 3D environments based on sensory information, then we'll be able to really effectively get around using autonomous aircraft. So, on to the next thing is, should that system fail, we have our first-person view right here. And this is just a mirrored image, again, of what you can see through these first-person view goggles. And so, should the crew member need to take control, there are some advanced features on here that will identify threats. You'll see some rectangles that are popping up to simulate those in just a second. There you go. And these are randomly generated, but they are representing that the system would still be helping the pilot, the pseudo-pilot, by identifying any objects that he needs to be aware of that are actually on a collision course with the aircraft. And so by using these goggles, he can see not only what's going on outside the aircraft, but can actually have enhanced vision by identifying threats that he otherwise may be unaware of. And that's basically it. This was a tremendous project to work on, think about, as well as to actually build. I had to use a water jet to cut out this galvanized steel plate you see on the front. And a lot of other mechanical engineering tools went into building this. So it was really fun to sort of cross paths with those guys and to do a lot of work. It was great though. We did win the Boeing competition, so our aircraft design was chosen of the two. And also when we came home, our smaller electrical engineering department actually got best of our department for the graduating class 2014 and second place in the entire College of Engineering for senior design. So we were really honored and happy to have that recognition after all the work we put into it. So not only did we learn how to use all these new tools and how to think about things more quickly, but we also did get to take away a little bit of recognition, so that was great. But overall, this was a tremendous project and an incredible learning experience, and I'm really happy to have been a part of it. So, thank you for watching, and I hope this has been interesting for you, and have a wonderful day.